Today is day 1 and we are solving merge sorted array 88th question on LeetCode. We are taking the questions from top interview 150 provided by LeetCode, and this is the first question. Okay, let's get started. So here it says we will have I will be given two integer arrays, num1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by a function, but instead sorted inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged and the last elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, every time I read a question I try to paraphrase it with my own words so that it's clear, and I want to make sure that I understand it correctly. So what I get it, input. We have an input of two arrays which are consisted of number array, and we also have another number array, just like in the description actually. And the first one has a length of m length, and the second one has a length of n. Actually, this one has a length of m plus n, and m means the first, like m elements are actual numbers. Let me explain. Let's just write the output first. Output should be another. Actually, we don't return anything. It's void or no output. If we are using TypeScript, it will be like just void or nothing. We don't have to return because we are changing the number, like the first nums1 array, and it should be like, yeah, it should work when we change it. Okay, let's what are the constraints of this question? Do we have any constraints here? Okay, let's actually Upwork has the answer to that. The nums1 length is m plus n, just as we described. Nums2 length is n. M and n is between 0 and 200. We may have an empty list or maximum 200 elements in both. And then, okay, nums1 and the elements inside the list can be negative, positive, between this range. Okay. Oh, will it stay blue forever? Okay. What I would do normally would be to write another test cases. So we are given these two test cases. Let's just take them for now. Okay, we actually have 3 test cases in this one, and we will also write our custom cases after this one. So here we have nums1 and m3, which means like first 3 numbers are actual numbers, others are 3. Nums2, and it says like basically there are 3 elements in nums2, and the merged result, it's nums1. It's actually nums1, it's not returning anything. Nums1 becomes 1, 2, and this 2 comes in place of 3, and then 3, 5, and 6. And the next case we have 1 element and no elements in the second array, and we just return that 1 element. And right here we have 0. We have m0, which which means just fill in here with any number you find from here. and we have a 1 here. We just replace that right here. Okay, I believe that should be clear. What I would normally do, like the first thing that comes to my mind would be using another array. Actually, the question would be much simpler maybe when we had 1, 2, 3 and 2, 5, 6, and we can create a new array and we loop through these two. We will have, like, we check, is 1 greater or it is 2. Both of them are sorted actually in ascending order as the question tells us, and we just say, yeah, 1 is less, and we move to 2 and check it with this one. They're both the same, so I just add both, let's say, or add this one, let's say, and then we move to 3 and check with 2. 2 is less, let's add it, and we have 3 and 5. 3 is less, let's add it, and now we have nothing to compare. We just add the rest of the elements from here. That's basically what it's asking for, but instead here we have this zeros to fill it in. Another case, like what we can do to solve every time, like when we have such a ascending order or such questions regarding the sort, we can take the different approach, like instead of sorting from the beginning, which may be problematic because we come here, let's say we have this 1, 2, 3 and these arrays. Let me initialize my pointers actually. Let's imagine we are looping through this array. We come here, we see 1. 1 is less than 2, yeah, okay. 2, okay, like 2 and 2 are equal, we can just go to the next one. We have 3, and 3 is bigger than 2. At this place, we need to take the 2, replace it to 3, and move 3 to the next one or to the end, and that's may get tricky, more difficult, maybe difficult for us. Or we can, like it says, we cannot, I believe the question says we cannot change the length, or we should not change the length of this question, I believe, right here. Let's see. Okay, I believe we cannot actually change. Right here at 3, we have to put 2 here and move 3 to the next one. But how do we know that? We see that next one is 5, so this should be 3, and then here we put 5 and 6. Putting these 2 and 3 maybe is a tricky part. If we had other values here, that may be like lots of if conditions and so on. And even if we splice a array in the middle, if we take, and for example, if we remove 1, 0 from the end and splice it and add 2 here, it will not only change these 2, it will also change all of the values after it, making its indexes, like incrementing in their indexes +1. Actually, like splice method is costly. It's not just one action when you insert into the middle of the array in most of the languages, as far as I know, including JavaScript. So here, the better solution, better way would be by going through the end of the list, filling in the zeros first. So here we come here and let's see, 3, 0, 0 and 0. We start from the end. We take 3, we take 6, as if they are two different arrays. We compare, 6 is greater, let's base 6 here. We move our pointer here. We actually have two pointers, the first one for this array, second one for this array, which was at 6 and moved to 5. Let me actually make them in 2 lines so that our pointers will be easy to move. Okay, we are here and we are here at the array, and now we check 3 and 5. 5 is the greatest here. We actually have the third pointer. If you have noticed, we are updating updating the values. Now we want to update value of this idx. We are decreasing it every time we update a value. We move 5 to left because we already used 5. Now we check 3 or 2. Actually 3 is the biggest, so we add 3 here, we move our pointer by 1, and we move our first pointer to the left. 2 and 2, it doesn't matter, add one of the two. And the next, we need to update this value. Here we have, let's imagine we added this one, and we move it here. We have 2 and 1, add the 2 here. The next, move to the next. Now we want to find out the matching value for the first index. Here, since like we set 0, it's once we added this 2, it's empty, so it's not pointing to anything right now, and we only have 1, which actually like we should compare as long as this one is not compare until not empty or pointer not equal to -1, let's say, bigger than or equal to 0. Yep, at this place like it's like -1 if we move it to the left. So we only have 1 here, we just add 1, and that will be our answer. For other cases it should work. For this case, let's take it. We have 1 item and our pointer is 0. Okay, which means we have 0 elements. Actually, one more thing to note before moving here. If you notice, we started at this index, and here we had m of 3, and the index we start would be m-1, which is 2. We are pointing to the third element with index 2. That's how we calculate the pointer for this case. And also for this case, we make it n-1. The n that's given to us, n would be 3. 3 minus 1 will be 2 again, right here. That would be easier to understand, I hope. Okay, let me just say this right here. Compare until not empty. Or here we have pointer 2, here we have pointer 1, and this one is actually pointer 2. Okay, and if we take that example of 0, we have m equals to 0, and m will just be -1. If in that case we have nothing to compare, but our array, this one, has 1 item in it, and pointer is pointing to 0 index. Right here, I'm taking this second example. We have nothing to compare, so if we have nothing to compare, we just add the values we find in the non-empty array inside the first array. That's one case we should just add. Let me say this. So this case implies for all, like P1, equal or bigger than 0, compare. If not, just add. Okay, let's now try to code. Before we code, let's write the time and space complexities. Time complexity. As you have noticed that we are going through the nums list once, but we are not checking these values, like we are going through m values and n values, comparing them all, which means we are using m plus n. We are going through m plus n items to get the answer. What about the space complexity? What are we using? We have 3 pointers. Pointer 1 for the first array, pointer 2 for the second array, pointer 3, which I have just removed actually, for updating the arrays, which is like valid index, let's say. So we are actually not using any other additional space. It will be big O 1, no matter like how big our m or n, this nums1 or nums2, we will always use 2 pointers, like 3 variables. It will not change, so that's a constant space. But time is m plus n. Okay, let's code it up. So what did we do? We loop through nums1, loop through nums2, and compare. It's actually not a loop. Pointers for nums1 and nums2. Okay, let me just start coding. Point p1. I will say p1 for the first pointer. It will be nums. It will actually be m minus 1. We have m already given, and I will also assign p2 right here, which will be n minus 1, and our pointer 3, which will start at the end of our nums1 array. We wanted to point to the last index, which is m plus n minus 1. These are our pointers. We have this condition: while p1 is bigger or equal to 0 and p2 is bigger or equal to 0 and p3 is bigger than or equal to 0. Do we actually need to check for p3? Let me think. Here we come, here we move. Okay, our pointer moves. We check. We never reach the case where before p3 becomes minus 1, these two become 0 or minus negative number. That's why we don't have to check for the third condition every time. And here, what do we do? The logic. Compare, add bigger val to nums1. Nums1, p3, pointing to 3. Okay, if nums1 p1, which is the number from nums first array, and we also check if it is less than or equal to nums2 p2, which means p2 nums2 current value here is bigger. We wanna just say nums1 current 0.3. That instead of this, let me just say valid so it will be a bit different as well. Valid point will be nums 2 p2, which is a bigger value. And we also say valid index. Okay, valid index. Just a second, let me replace. We decrement it, and we also decrement p2 pointer 2 because we just added this value. So we wanna now look at the next value, like we added 6. If we check here, we compare 3 to 6, 6 is bigger. We wanna move our pointer 2 to 5, which is decrementing it. And else statement, else means this time p1, like nums1 p1 was bigger. We wanna do the reverse. Let me just take it. Nums1 p1 will be here. We wanna decrement p1, and we wanna decrement valid idx. Okay, one more thing to check. As you have noticed in our last input, when we had like this 0 and pointer 1 was actually -1, we wouldn't even enter this while loop because it's not bigger than 1. But at this case, our answer will return false. What we want to check is if here we check if p1, let's say, oh, just a second. Here we have p2 bigger than 0. Let's say if p2 is bigger or less than 0, equal to or bigger than 0, even if it's 0, it means there is one value inside it right now. Okay, if it's that case, we want to let's it while loop, while p2 is like that, keep adding, just keep adding, because it means p1 pointer 1 first array has been iterated. We are only iterating through the second array which is remaining. So for this case we only want to add this thing. We want to add values remaining in the nums2 and decrement p2. Similar case, if we end up with more values in p1, what will we do? Actually, if we end up with more numbers in p1, we don't have to do anything. That means, imagine like we had this array of 1, 2, 3, 4 and 9, 7, and we had second array of 4 and 5. Let's actually take 6. We check it here, we put 7, we check 9. It should be increasing order actually, like that would be invalid input. The first case, we have 6, 9, 9 stays here. Actually we also have 0 here. So in our algorithm we check 9 and 6. 9 is bigger, we put 9 here. The next, we want to check this. This is our valid index, let's say. Valid, we want to validate maybe. Oops, let's change. Yep, right here. And we check. Our pointer 1 is actually at 7 at this point. 7 and 6. 7 is the answer. Our pointer 1 will be 4 and 6. 4 and 6. 6 is the answer. And right here, our while loop will quit because this one becomes -1, but p1 is more than 1, which is currently at 4, which is actually like 3. But we don't have to do anything because the rest of the array is sorted already, and just going through it one by one and replacing it with itself will just be a waste of time. That's why I will remove this case. We will only add while p2, like nums2 is non-empty. Okay, valid IDX. And we don't have to return anything. Let's run our project. Okay, it's accepted. Let's try to submit. Okay, so it's working. It passed. Thanks for watching. See you on the next one. If you have any suggestions, improvements, please let me know.